Take some time and go through Lab 6, the volcano lab. Kind of explain what you need to do to get this done successfully. Now, just practically speaking, you can print out this whole lab. There are some drawings in it. That makes it easier to draw on the paper. You can scan it or take pictures of each page and upload it, and I'll grade it that way. Or you can fill out, say, if you have Microsoft Word the way I do here. I can't draw, I don't have any draw tools, so you can fill out all the text that you need to. And in the areas where you need to sketch something, like in item 3B, you can wait to do that. Perhaps save it as a PDF and then draw within a PDF editor. You could try that. Or you could draw all these sketches on a separate piece of paper. Just make sure they're numbered for me and submit that separately. I'm just trying to think of all the practical ways we can get around using paper if needed. Um, yeah. All right. So this is using Google Earth, and you don't have to import any files to it like with Lab 3. You just need to be able to navigate to coordinates, which we give you for all the questions here. And you need to be able to use the ruler tool in order to fill out all this information. I'll show you what it looks like. So first off, our coordinates are negative 33.25, negative 70.35. So I've already typed that in here, and that led me to Chile. And the instructions were to zoom out so that we're centered on Santiago. And there is Santiago. I don't have my labels up right now, but that's what the deal is. And the eye altitude needs to be at about 1,000 kilometers. So I'll zoom out a little bit more. I'm looking. Okay, my eye altitude down here is 1,094. That's fine. And just tilt it then. Look northward, a bit northward along the coast, and just describe the features that you see here, starting with this dark, deep area on the coastline into this mountainous area, and then beyond that. Kind of a rapid change in vegetation from the coast and the mountains to more inland on the continent. Okay, so that part shouldn't be too terrible. Now, it is repetitive in the way that you go about visiting each volcano in Google Earth. We'll go to the first one, which isn't far from what I just showed you. So I'll just copy these coordinates and paste them here. It takes us right to the volcano eventually. All right. So here we are looking at this stunning volcano. You want to make sure that you can see your elevation data. Sometimes I can't see mine, and that's because terrain isn't checked. So we want to look at the base elevation, and there will be somewhat of a range of answers. The base should be kind of the point at which, if you were standing on the ground, looking at this from the side, that would be where you see the slope really start to change. And you could say it's about here. I'm tracing it. Because if we were to zoom out, we see there's another volcano to the south actually here. So, I mean, I'm trying to separate this and isolate this from the other features. So I'll pick a base elevation somewhere around here. It could be like 2,600 meters. And make sure that you're in meters for this as well. If you're not in meters, you need to go to options and choose meters, kilometers, rather than feet and miles. You can also change to decimal degrees. Doesn't matter. You can search for either decimal or degrees, minutes, seconds in the top left. But to save you the headache of converting your units, please just make sure you have that. Okay, so I find my base elevation here around 2600. It does vary, it's a little higher in this area. The max elevation, you want to look around the rim, of course. Just moving my cursor over here and looking at the bottom right, I'd say the elevation is a little upwards. Max, it's a little upwards of 3,800 meters. Okay, so that's something that gets filled in. Bring that up. So maximum height, base elevation. And then to find the relief, you just subtract the base elevation from the maximum elevation. So kind of a gently sloping volcano would have a lower relief in meters. The base width, that shouldn't be too painful. All we have to do is take our ruler tool and kind of remember where we said the base elevation was. Make sure it's in meters and just trace along the volcano. I could do something like this. It says map length. That would be your width. All right. And you write that down in your lab. Make sure, I haven't just said it, but yeah, make sure it's meters. You can choose all different options. Some things I've never even heard of. Stay in meters. So then you take that base width. To find the average slope of the volcano, you take the relief that you found, divide that by 1/2 of your base width, and multiply by 100. Okay, we'll use this data in the bottom part of the lab. Like I said before, there are various ways you could sketch it. Sketching is important because it kind of imprints it in our memory. Some of you might be able to use tools to draw it right in here in Microsoft Word. I don't have that on this computer. I can print it off and draw on there, or I can convert this to a PDF and probably do it in Adobe and save it and upload it that way. Composition, though, we want to think about that, and we've been through it in lecture, but our biggest indicator for composition in Google Earth is just color. Some of them are kind of hard to determine, and I understand that. But if you see darker volcano, say in the middle of the ocean, you'd have a lot of mafic material coming out of that. It's likely mafic. If you're kind of on the edge of a subduction zone, you'll probably have intermediate composition, and if you're further inland in the continent, it's probably going to be felsic. Mafic, looking for dark material, intermediate, kind of a mixture of light, dark, reddish, and felsic is mostly light material. So you'll tell me what you think and explain why you determined that. That's very important. It's worth points. So when we go to like item D, we'll think about the geologic hazards. Now, hazards could be ash, landslides, and of course the proximity to a population, and just kind of name what you see in the landscape that could be impacted by an eruption. For item E, when I say likely tectonic setting, it could be, say, a subduction zone with a convergent boundary. It could be a hot spot, like in the case of the Hawaiian Islands. It could be a divergent boundary, like the mid-ocean ridge. Subduction zones have deep ocean trenches associated with them. So do you remember that? And then with that, you're going to guess the volcano type. And as a hint, we have kind of the volcano types listed at the end of the lab. I'll accept a variety of answers, but because some of these mean the same things. Like a shield volcano, that's one thing. Composite volcanoes could also be, say, stratovolcanoes. Caldera volcanoes, we have many of those across the globe. That's another option. And each of them are characterized, they could have a wide dome, a steep cone, or some kind of open crater with a raised rim. So think about that as you go through. Try to think if there's anything else I want to add. The process is pretty similar for each question. You're kind of storing all this data for what comes at the end. Okay. Pardon my scrolling. Okay, so this part too, I don't want it to be too frustrating. It's easy enough if you've already printed the lab. You can just take the width. Fortunately, now we're in kilometers, not meters. So make sure you have that converted from meters to kilometers. Plot that. You can just plot it as, say, a point on this. You can draw a bar in. You can't do it with any source data file because I don't have like a separate Excel file linked to it. So um, if you've gone through and done this whole assignment in Word, I would just convert it to a PDF and like open it in Adobe and then draw on it, like put points on it or however, works best for you. Or print this section, take a picture of it and upload it for me. Relief, again, you're taking the values that you got for each volcano and putting them in this chart. All right, relief is in meters. Slope is a percentage, so you'll plot that. And composition is just whatever type you selected. And you'll note we don't have ultramafic as an option. So each of these volcanoes, based on the color that you see, or even research that you do on the internet or in the book, you'll say whether it's dominantly felsic, intermediate, and mafic. And some of them, some people will say are felsic, others will say are intermediate. And knowing, what you have to go on, I will probably uh, be very generous in how I grade that part. So as you do this part in page 9 of 10, summarizing the volcano type, composition relationships, you got to fill in the blank. And just for the fill in the blank parts, use the items in these tables to fill that out. That keeps it clean and it keeps the language consistent, I'll say. So understand that those two go together. All right. Believe it or not, I found this lab to be very useful in appreciating volcanoes. And I hope it gives you some interesting perspective too. If anything comes up, you can send me an email and we'll figure out how to solve the problem.